Okay, so the other day we talked about the parent function, right? You should know these 5 points, this point, 0, 0, 1, 1, negative 1, 1, and negative 2, 4. You should have those points memorized. But this is new. This is a new equation up here, which is we're going to talk about is the general form of vertex form of a parabola. So a vertex of a parabola is like when you have a parabola like this would be the minimum point on the parabola, and it has the coordinates of h comma k. So we call that the vertex of the parabola, which would be the lowest point in this case, the minimum point of the parabola. Um, and so this h value, think of x as moving things horizontally, right or left. So inside of the parentheses, your things are going to move right or left. K is a y value, which is a vertical movement. So outside of the parentheses, that K value moves it up or down. And the A does a couple of things we'll talk about in a couple of minutes. But as far as right and left horizontal movement, it's all in the H and the K there. So let me show you what I mean. So let me just show you. This is the y equals x squared graph. If you look at y equals x squared, that's our parent graph. Um, at the bottom here in this a is 1, right? Because 1x squared. H is 0. It's not moving right or left at all. And K is 0. It's not moving up or down at all. And so if I were to change H, for example, to 2, now I moved it to the right 2. So H is positive 2. Notice the formula down here. It's x minus H. So x minus positive 2 is actually x minus 2 there. So what's weird is the vertex is a positive 2 comma 0, but the formula has in the parentheses x minus 2. So it's almost the opposite of what you think for horizontal movement. So if I want to move it to the left, where h would be negative, so h is negative 3, then it would be x minus negative 3, which is boom, boom, plus 3. So in the formula, it shows the opposite of what the h value is, which is negative. It moved left, but yet the formula says plus 3. So h movement is usually the opposite of what you would normally think it would be. Whereas k, because the formula says plus k, it's exactly what you think. When you add 2, the function moves up 2, just like you might think it would. If you subtract 3, the function moves down 3, just like you might expect it would. So h and k are horizontal and vertical movement there. So right away, when you see this, if you compare this to the formula, right, ay equals a times x minus h squared plus k, you can see that's definitely horizontal movement. That's your h value, which is your x of your vertex. And so this is actually going to move the opposite of what you think. X minus negative 2 is like x plus 2, so it's going to move to the left 2 units. So in words, every point moves to the left 2. So here's what that looks like. So 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So every one of those points moves to the left 2 units. So this point up here moves to the left 2. This one moves to left 2. The vertex moves to left 2. That's the vertex at negative 2 comma 0. That's your H and K. And then that point moves, it covers up that other point, and this one moves up here. And so you have your parabola here. So this would be kind of like this. It's okay to leave those other points there. It's not a big deal. Just make sure you know the blue graph is your actual graph of this parabola. Let's try this one. So again, if we can compare it to kind of your parent graph there, or your vertex form. So y equals a, which is 1 in this case, of x minus h squared plus k. I don't know if you can tell, but the parentheses are kind of around the x there. Right, so it really doesn't have any horizontal movement. H is 0 there, so x minus h is just x squared, right? But the k value is negative 3. So it looks like the vertex is going to be at 0 comma negative 3. That's going to be your h and k. Now, typically the way we do this, you could do it that way, but 0, 0, 1, 1, 2, 4. So those are your parent graph points. Every point, if you say this in words, every point is going to move down 3 units. So I'm going to move everything down 3 units. Down 3, down 3. And I'm going to draw my line for my parabola. I think I forgot to mention axis of symmetry. So it says identify the axis of symmetry. So the formula is x equals h. So like in this case, it's a dotted vertical line where x equals -2, right? It's -2 because h is -2 there. If you want to do the axis of symmetry here, it would be x equals 0. Now this is a new kind of transformation. So let's look at the this here. So if a is negative, so if a was instead of being +1, let's make a -1 and see what the graph looks like. And it looks like the original graph is there up top, and the new graph is down below. It looks like it just flipped over, and now it's facing downward. It still has the same vertex of 0, 0, and it did do that. But we say mathematically this is a reflection over the x-axis. Is the words we use. And so every point, like 1, 1, move to 1, -1. 2, 4, move to 2, -4. -1, 1, move to -1, -1. And -2, 4, move to -2, -4. So doing that just kind of, so we're going to say this in words here. So we would say reflect, that negative reflects, because it's out front, over the x-axis. You need to specify which axis it's reflecting over. Typically, the way we do this, so in this case, a would be equal to -1. That number in front of the x minus h is -1. So whenever a is not 1, typically the way I do this is, and this will help you on harder functions as well, we take the parent graph points that we know and love, that you have memorized, and we multiply all those values by -1. All the y values. So that's going to be -1, or sorry, 0 still. That's 0 times anything 0. That's going to be now -1, now -4, now -1, and now -4. So everything just changed negative except 0 stays 0. My 5 points now will be going downwards. So you plot those 5 points, and you got your graph. So again, that's typically when a is not 1. Go ahead and just write out the paragraph points, multiply the y values by whatever a is, and that will take care of that transformation, in this case, reflecting over the x-axis. Let's talk about just generic form of a function. So, because really all functions move the same way. So I'm going to say it this way. Let's say this is my parent graph. Y equals f of x. So if f of x is some generic function, in other words, like, I could change it to an absolute value function. Well, guess what? The formula, it still works. X minus h moves it inside the parentheses there, k moves it up and down, the a value will reflect over the x-axis, etc. So if I were to do something like this, y equals f of x minus h plus k, right? So what's happening there is the h is going to move it horizontally, the k is going to move it vertically, right? And if there's an a in front, if there's like an a times this, that's going to, if a is negative, right? If a is less than 0, then it's going to be reflection across the x-axis. So all functions pretty much move the same way. So we're going to learn about different functions, but sometimes you even see it in this form where, if it was f of x minus 3 plus 5, that means you're taking the original function, whatever it was, you're going to move it to the right 3 units and up 5 units, right? If there's a negative in front, that's going to reflect it over the x-axis. So sometimes you see this form, and that's what they're doing. They're just saying any generic function. It could be any kind of function, because really every kind of function moves the same way. It doesn't matter what the function is, it's going to move the same way. So we're about to talk about absolute value functions here. So let's see what that looks like. So the absolute value functions, hopefully you have the parent graph memorized, 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. And the graph of that, of course, looks like a V for absolute value. And so our parent, our function, kind of like vertex form, it's a, instead of x minus h, it's absolute value of x minus h, and then plus k is outside the parentheses, so outside the absolute value there. So it works the same. Again, we're talking about every function moves the same way. So this one's going to move it right and left. The h value, the k value moves it up and down. The a, so far we know if it's negative, it's going to reflect over the x-axis. We'll learn something else as well in just a minute, but let's start with just that. So x plus 2, that's going to move it to the left 2 units. So in words, to the left 2 units. And the minus 4 at the end is going to move it down 4 units. So start with your parent graph points that you know and love, 0, 0, 1, 1, 2, 2. And every point is going to move left 2 and down 4. So the vertex is now left 2, down 4 right here, left 2, down 4 right here, left 2, down 4, left 2, down 4, left 2, down 4. Pretty soon you have your graph of this new absolute value function. Looks something like this. And if you wanted to draw the axis of symmetry, it also has the axis of symmetry here. That vertex point is at -2, -4. That's your hk. And so the formula for this is x equals h, which is -2 in this case for that dotted vertical line for the axis of symmetry. That's a minimum value for this. It's the lowest it goes, and that would be a minimum value of -4. Let's look at this one. Again, since a is not positive here, typically what I do is I just write out all the ordered pairs of the parent function. So 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. And so all the y values are being multiplied by, this is going to reflect it over the x-axis. So the y values being multiplied by a, so that's still, well, that's still 0. That's going to be now a -1. It's now a -2. It's now a -1 and a -2. So if I plot those 5 points, it looks like it just flipped over the axis, called reflecting over the x-axis. Those are those 5 points. And then to finish it off, this is going to move it up 3. So up 3 is that transformation. So that moves up. That's now the new vertex. Those points all move up 3. And you can graph your absolute value function. It looks like this. And if you wanted to write the axis of symmetry, right, it's at x equals 0 would be the equation of the axis of symmetry there. So now we're talking about the let's see, square root function. So you know those 3 points. Hopefully you have it memorized, 0, 0, 1, 1, and 4, 2. The graph kind of looks like it has a starting point, kind of moves up, something like that. And this one has 2 transformations. So the first one is a negative. Again, that reflects over the x-axis here. So it's going to reflect because it's out in front of the function over the x-axis. And so typically what I do is I write out all all 3 points, in this case, 1, 1, and 4, 2, right, 4, 2. And all the y values are going to be multiplied by -1. So that's going to be 0, -1, and now -2. So those 3 points are 0, 0, 1, -1, and 4, -2. And then you're going to take those points, and it looks like everything is going to go to the left 1 unit. So left 1 unit, because it's x minus h, x minus -1 is boom, boom, +1. So it's going to go left 1, the opposite of what you think. So that's the new, it's kind of like a vertex. We don't really call it a vertex, but it's similar. It's the starting point. Vertex is usually like a minimum or maximum. This happens to be the maximum of this graph. But it goes, this is an arrow on this side. The 0, -1, 0 is just a starting point. -1, 0 doesn't really have a name, but that's where the graph starts. Now, this is the trickiest one we've done so far. It's very unusual. We don't see this a whole lot. But when the negative is not in front, here the negative was in front, but here the negative is kind of attached to the x. So this is going to reflect the function, but not in the way you might think. Well, this one reflect over the x-axis. This one's going to reflect over the y-axis. So if you take this graph and you go, okay, I'm going to reflect this over the y-axis. So you take the points you know and love, 0, 0, 1, 1, 4, 2, and you're going to reflect those over the y-axis. So this 1, 1 point goes to 1, -1. 4, 2 goes to negative 4, 2, and 0, 0 stays the same. So those are now your 3 points on your graph, and then you have to, of course, move everything down 2. So this one's going to move it in the downward direction, downward 2. So my new starting point is right there at 0, comma, negative 2. That point is there, and that point is there, and the graph looks roughly like that. By the way, tomorrow we're going to talk about what happens when A is not bigger than 1. We'll get there, but we're kind of taking our time with this lesson. Okay, so let's talk about this equation. So on this one, if you know your general form of an equation, y equals a times, this is a parabola, so x minus h squared plus k. So this vertex looks to be maximum of the graph is at 2, negative 2, positive 3, I guess. So that's your h and k. So I know my h, I know my k. The one thing I don't know right now is my a value. So I've got to figure out, in order to write the equation, I need the a value. Now, if you understood the graph of the parent function, you might be able to guess a. Here's what I mean. Right away, I'm thinking a is negative. The reason is the graph is opening downwards, not upwards. So it's been reflected over the x-axis. So I think a will be negative. And right now, if you know the pattern over 1, down 1, over 2, down 4, over 1, down 1, that looks very similar to the pattern we've seen in the past. So I think a is going to be negative 1, but let's prove it. Let's pick a point here. So let's take this point right here. Let's use 3, 2. So that's going to be, I'm going to call that h, x, and y. The vertex is h and k. 2 and 3 are a special point, but any of these other blue points would be an x, y point. You could pick any of them and use them just fine here, but I'm going to use that one. So I'm going to plug in all the values here that I can. So y is 2, a I don't know, x is 3, minus h is 2, plus k is 3. So I'm going to solve this. This is 1 squared. So this is 2 equals a times 1 plus 3. So a equals negative 1. That makes sense. That's what I thought it was going to be. So the equation would be y equals negative 1 times x minus 2 squared plus 3. There's going to be 3 transformations here. So first one is reflect over the x-axis. You want to specify the axis. This one is going to move it to the right 2, opposite of what you think, inside the parentheses. And outside the parentheses, it's going to move it down 1. And you said those, describe those in words. So this one, again, it's kind of like this one down here, where we did the formula. So if you recognize the vertex is always hk, any generic point with that is going to be xy. This is a quadratic question. So if you start with the quadratic equation, a times x minus h squared plus k. If we plug in everything we know here, solve for a, we should know what a is. So negative 1 equals a times 0 minus 1 squared minus 2. So this is really 1, square force of negative 1 equals a minus 2. So a equals 1, so my formula is y equals a, which is 1 times x minus 1 squared minus 2. So again, now I think you're ready for homework. Sorry about doing the wrong lesson earlier, but now we have it corrected here.